Hello everyone, this is going to be the last video for today's lecture. We just went through demo problem 1. I used the subreddit UW Madison to show you how you can poke around a JSON file whose format that you're unfamiliar with. Feel free to explore other subreddits like Python or any other subreddit that you're interested to explore. I'm not going to go through demo problem 2, but I just want to briefly talk about this particular problem. The city of Madison has a data set which has Madison bus alerts. This is actually a real-time data set which gives you data in the form of JSON file format. You can try to access this data set by sending a HTTP GET request to this particular URL directly on the City of Madison website, or you could just use a snapshot that I've uploaded as part of the course website. The cool thing about websites which have real-time data sets is that they keep updating the dataset JSON file once in a few minutes or so. Wouldn't it be really nice to write a Python program that can download the JSON file once in every refresh time period? That's something for you to explore if you're really interested in doing that. We are going to wrap up today's lecture by going through demo problem 3. Demo problem 3 is going to involve downloading multiple files. Let me go ahead and switch over to Jupyter Notebook. Here is the URL to a file which is called states underscore files.txt. This particular file has a list of JSON file names. As you can see, this particular file has a list of JSON file names for each of the US states. So what we are going to do is we are going to write a program to download data from each of these files, and then we are going to convert that data into a data frame so that we can try to answer meaningful questions about the data which is contained within all of those files. So I'm going to define a prefix URL here instead of defining URL. And sorry, looks like I had something else on my clipboard. Let me copy the URL. Instead of having the entire URL here, I am going to get rid of the last state underscore files.txt part, because that part of the URL is going to be common in order to access each of these files. So let me show you how you can access alabama.json file. Notice that I'm just replacing states underscore list file name with alabama.json over here. All right, let's first fetch the list of files by trying to send a get request to states underscore files.txt. I am going to do that by using the request module get function. Instead of saying just prefix URL, I will have to say prefix URL plus states underscore files.txt over here. Let me go ahead and erase for status, and I just want to display what is coming out of this particular HTTP GET request over here. So we are getting this huge string which is not really formatted well. Please observe that every state's file name is followed by a new line over here. So I'm just simply going to split this string by new line, and that's going to give me a list of all the individual file names, right? Why does that give me a list? Recall that the split method on a string always returns a list of strings based on the delimiter that you want to use for the split operation. So I'm going to capture the return value into a variable called state files, and let me go ahead and display the content of state files. All right, we have a list of all the files over here. What I want to do here is I want to write a program to download each of these files. So I'm going to have to write a for loop to do that, right? So I'm going to say for state in state files. Let me see. I'm going to use the underscore notation here because that's more preferable. So let me go ahead and do that. For every state in state underscore files, I just want to send a HTTP GET request to fetch that particular file, right? Since we're just starting to write this program, I want to test it just on the first 3 files instead of trying to download 50 files over here. So I'm going to say URL equal to prefix URL plus state file name, and then I'm going to go ahead and send a GET request for the URL, and I'm going to raise for status, and let me go ahead and get r.text, and I want to just print r.text over here for the first 3 files. All right, I have to rerun my previous cell because I changed a variable, fixing that. Prefix URL variable reference is incorrect. I have all caps for URL. Right, there we go. So we are getting 3 dictionaries. Let me show you the content of Alabama.json file over here. Notice that we have a dictionary which contains 3 key value pairs. This just represents the census count of population for each of the states in the 2000 census, 2010 census, and 2015 census. I know that we have the 2020 census information out, but I haven't gotten around to updating this dataset with that detail. All right, so far our code is working well. Each of this JSON file contains a dictionary. So I'm going to go ahead and use the r.json function to call the load s function on the JSON module, and I'm going to capture the return value into a variable called data. So let me go ahead and print data over here. Wouldn't it be nice if we can keep track of the name of the state along with the details associated with that state? Data is a dictionary. I can very easily add a key value pair into a dictionary by saying dictionary of key equal to value. So I'm simply going to say data of name equal to state. State is going to contain uh, the file name, but that's good enough for us to identify that particular name, correct? So I told you that we want to eventually be able to create a data frame out of all of the data that we are reading from all of these files. The easiest way for you to create a data frame here is to add all of these dictionaries into a list, right? So I'm going to go ahead and define a list called rows outside, and I'm going to just say rows dot append of data over here, and let me get rid of the first 3 file sorry, not file, list entry in my for loop statement over here. So I'm going to now run the code for all the 50 files. Notice that it takes quite some time to go through and download all the files. That's because HTTP download is quite slow. So let's take a look at what is there in the rows variable over here. We have a list of dictionaries which has all the population information for the 3 census period. So I'm going to convert rows into a data frame. So I'll have to first import data frame. So I'm going to say from pandas import data frame. Let me go ahead and convert rows into data frame here. I can simply say data frame of rows, and that's going to return a date, sorry, that's going to give me a data frame. So let me go ahead and display df over here. Notice that it's taking again a long time to fetch all of the information over here. You can very easily capture all of the data into a variable and not run your for loop more than once. So I can just do that by converting this into a function. So let me show you how to do that. So let me define a function read state JSON data, and I'm just going to define rows inside my function over here, and I can go ahead and return data from inside my function. Instead of every time calling this function over and over again, I can call this function once and capture the return value into a variable called rows. And I was supposed to return rows here and not data. And then I can go ahead and move the data frame code into a new cell. I'll just like let it run one final time. And now I should be able to use the variable rows how many ever times that I want to. And this will be much faster because I don't have to download every file every single time over here. All right, we have a data frame over here. Let me do a head on the data frame, and let's explore things a little bit here. We have the name column at the end here. Wouldn't it be nice if we had the name as the index for every row? That's because that's a more meaningful row index than just using 0, 1, 2. You can do that by saying df.set index of name. I'm saying like take this column and set that column's entries as my row index. This will return a new data frame for me. So I'm going to capture that back into the variable df. Notice that now our row index became the column value name. That's so much more meaningful over here. All right, since we have a data frame here, we can do cool things like sum up all the population across various census, or you can also try to compute mean population count across various census years over here. You can transpose your data frame by using df.t. So that will just like convert all of your rows into columns. So you're going to have 50 columns for each of those states, and you're going to have 3 rows for each of the census years over here. And after you do that, you should be able to use df.t to find other useful information like max population among the 3 census years, or the mean population among the 3 census years over here. All right, that's it for today's lecture. Feel free to explore any of these examples in more detail.